Alright guys, today we are continuing our discussion about the scientific method. Scientific method continued. The other day, we were talking about Francis Bacon and how he's known as the father of the scientific method. Sorry, I'm having technology issues today. He said that we must ask a question, that we should come up with a hypothesis, that we test that hypothesis with an experiment, we make our observations, we're going to analyze our results, and finally we're going to come up with a conclusion. We're going to go over what each one of these are, and we're going to go over an example from class. Alright, so we asked in class, what is a question? A lot of you guys said, well, a question is when I want to know more about something. Something I say when I want to know more about something. A question is basically a statement that you make to gain knowledge. You want to know more about something. A statement in order to gain knowledge. From our lab the other day, we talked about our question that we were asking was, do Bigfoot like apples? So we read a whole article about Bigfoot, and our hypothetical experiment would be to determine, do Bigfoot like apples? Whoa. Having all sorts of technical difficulties today. Our next step is to come up with a hypothesis. An hypothesis is a potential answer. A potential answer to the question. It's your best guess. And we said, most of us, we would like to think, since we all liked apples, our hypothesis statement is yes. We think Bigfoot will like apples. So, if your hypothesis is a potential answer, I just want to talk to you for a second about different levels of hypothesis. The first one I want to talk to you about, the hypothesis, is just the potential answer. One level up from that is a theory. A theory is a hypothesis that has been proven true many times. So, a hypothesis has been proven true many times. That is what a theory is. Sometimes you hear people say, I have an idea about the way something works. What they actually have is a hypothesis. This is a potential answer. And they say instead, I have a theory about that. They don't really. What they have is a hypothesis. One level up from a theory is a law. That sounds very important. And it is. A law is a detailed description about the natural world. That has been shown to be true. Under every condition ever. We talked about what is a theory, and you guys came up with Einstein's theory of relativity. That is an idea that keeps getting proven to be true. Maybe someday it will become a law. But they're still testing it because they're still pushing the boundaries of physics, and they're finding new things, and they go, I wonder if this will prove Einstein's theory of relativity wrong, and it never does. A law, like the law of gravity or Newton's laws of motion, apply everywhere that we know about physics. So it doesn't matter what kind of planet you're on or what part of the universe you're in, we know that gravity may be stronger or weaker, but it is a force that's still going to affect everything. And that is why it is a law. So we have our question that we want to answer. We have our best guess, our hypothesis. The next thing we're going to do is test it. An experiment is an ordered investigation. And the point of it is to prove or disprove your hypothesis. What will our experiment to determine if Bigfoot likes apples, what will that look like? Sorry, I switched my pens accidentally. All right. Well, we know that we are going to need apples. And we know from our reading that we have a whole neighborhood of backyards that we can use. And that we probably should have cameras. A few of you suggested that we should have traps in place as well. That we're going to have 15 yards. 5 will have apples. And 5 will have some other fruit. And 5 will be empty. No fruit or apples. And we are going to watch for several nights in a row. Maybe even for weeks. Right? Because we don't know what the pattern of the Bigfoot are going to be. How often do they actually come looking for food? That's going to be our experiment. While we're running our experiment, we're going to make some observations. An observation is using your senses. To gain knowledge. And what observations might we make? Well, hopefully we'll actually see the Bigfoot. That would be something. So we're going to see him. He might be kind of stinky because he is an animal. So we might smell Bigfoot. We might find tracks or hair samples. We might even get a picture of him on film. Or, if we're really lucky, he will be in a trap. Wouldn't that be something? These are all observations we're going to make. A lot of the apples will be eaten. Because we know that they're kind of big. So these are all observations that we could make during the course of our experiment. Now, suppose we have 15 yards. We're each in a yard, and only one of us sees Bigfoot. Can that really be counted as a true event? And the answer is kind of no. Because in order for it to be a fact, in order for something to be a fact, it has to be an observation that has been confirmed. So maybe there were multiple eyewitnesses. Then it is true. So confirmed many times. Sorry. So once a fact has been confirmed many times, then it is considered to be true. So if 5 of our friends saw Bigfoot and we had tracks and hair and a picture, then we might believe that they were stating a fact when they stated that they saw Bigfoot. We're going to take all of our observations and we're going to analyze them. This means we are going to compare the expected result, what did we think was going to happen, to the actual results. what really happened. Who knows what will really happen? I would like to think we're going to try to figure out, did we see a Bigfoot? That will be the analysis. Who knows? Finally, once we have all of our information and we have analyzed it, we're going to make a conclusion. The conclusion is a statement that you make about the hypothesis. So it is a statement about the truth of the hypothesis. Is the hypothesis true? I hope that the answer is yes. But let's imagine that the answer was no. What happens then? Well, what happens then is you maybe say, did I ask the wrong question? So depending on what your conclusion statement is, now you're going to go back up. This is where I miss having my mouse. Now you're going to go back up and ask a new question. That question is going to lead to a new hypothesis. Your hypothesis is going to lead you to a new experiment with new observations, a new analysis, and a new conclusion statement, which may lead you to ask another question. And you are going to repeat as needed. So, if no Bigfoot comes to eat apples, does that mean my experiment failed? No, it just means that maybe I was asking the wrong question and I need to run the experiment again. That is our discussion about scientific method.